Hi, this is Sairam Reddy Jillala, and today I am explaining my project about IoT powered dynamic bus allocation system for enhanced public transportation. And coming to the introduction, so using the real time data from the IoT sensors mounted on the buses, which system can be dynamically optimizes the routes, cut the wait times, improves passenger experience overall with the potential to complete transform public transportation in the cities through the globe. And by continuously analyzing the data streams from the buses, traffic conditions, and passenger demands, the system dynamically adjusts the bus route schedules time in real time, and ensuring buses which are deployed and they needed the most. And coming to the proposed system, it should be able to generate the routes for the bus vehicles, making the adjustments of the already existing ones dynamically while processing the real-time traffic data. It evaluates the traveling parameters like distance, time, speed, and intermediate waypoints, which in order to identify the most effective route connections. Example with the ones with the lowest traveling time between the stops of each bus line, and keeps the corresponding time updated. And it should facilitate the efficient distribution of vehicle resources, estimating the minimum number of operating buses which are required in order to transport the passengers in the each bus line. Coming to the hardware components, we use the IoT sensors such as which are used for the collecting the real-time data and for the various parameters such as GPS location, speed, passenger load, fuel communication, health in engine health, which includes the GPS modules, accelerometers, RFID readers, and environmental sensors. For onboarding computer units, which are responsible for analyzing data collected by the IoT sensors in the real time. They consist of like microcontrollers such as Raspberry Pi, single board computers, dedicated hardware accelerators such as GPUs, which are like the processing time will be very fast, and the cryptographic and accelerators which is used for security for data processing tasks. In coming to the software components, we use the C programming languages, C++, and Python, and frameworks are used as TensorFlow and PyTorch, and the databases are MongoDB, and IoT environment as an Arduino IDE, and development tools like Docker. And coming to the communication interface, we use the Wi-Fi, which is used for communication between the IoT devices which are installed in the buses in the central server cloud platform. It facilitates the real-time data transmission. So for Bluetooth, we use it for the short distance communication between the IoT devices like passengers which are in the buses, like ticketing, onboard entertainment, information system, HTTPS. These are widely used for communication between IoT devices and cloud platforms. For the Ethernet, we use the local communication for onboarding buses within the vehicle. For V2X vehicle, we use like applications like collision avoidance, traffic management. For DSRC, which is dedicated short range communication, which is used for the roadside infrastructure, traffic lights, and etc. And coming to the system architecture, here we are using public transport system which contains of Internet of Things, which contains various modules such as passengers, vehicles and roads, social events. So we collect the historical data, and using some algorithms we use the vehicle arrival time and the number of passengers in the bus stand, and then we transport the flow analysis, vehicle control optimization, vehicle scheduling algorithm, and we assign the crew based on the uh, people's flow. For functional requirements, we use the real-time bus information, which users can track the real-time bus, and route planning and navigation, which plans the how which route the bus should they travel, and accessibility features like the disabilities person should have the special needs, and feedback and reporting, which the users can provide the feedback and alerts and notifications for the about the buses and through the SMSs or like that. And coming to the non-functional requirements, the response time, the user should not take much longer to uh, access the information, and the scalability. So The system should be accommodate growth in the number of buses and secure communication. The communication between the devices and servers should be very secure and should not leak the information in between them. And the energy efficiency, the system should minimize the energy consumption in the buses for the IoT devices which he has used. The modularity, the system should be designed in the modular components and well-defined interfaces to facilitate the maintenance and updates of the future environments. And coming to the operational environment, we use the embedded systems for the bus monitoring in which is installed in the buses, and those data is accessed by the user through the mobiles over the internet. And the conclusion, the final conclusion is the IoT powered dynamic. This project mainly holds the immense potential for changing the transportation, offering real-time tracking, obtaining the route planning, enhanced passenger experiences, and then by leveraging IoT technologies such as sensors, wireless communication, and data analytics, the system enables transit agencies, which improves the operational efficiency, reduce the congestion, and mitigate environmental impacts. Additionally, the system empowers the passengers with access to accurate, up-to-date information, leading to a smoother journey. And this is the references which I have used for the project. And thank you.